talk about scientific notation and significant figures, this is not really that helpful for a math subject, but it's very helpful to all your science subject, like talking about significant figures, like how many decimals we need to leave. So that's what we learned today. So the numbers written in scientific notation are expressed in the form of a times 10 to the power of something. Okay, this power can be positive or negative. Okay, can be positive or negative. Okay, so why we use scientific notation? When some number is extremely large with a lot of zeros at the back, we don't want to count the zero like 1, 2, 3, 4, like 10 zeros. We're trying to use an expression that I can directly see how many zeros there. So I become 10 to the power of something. Or some number extremely small, like 0.0000058. So we're trying to make it 10 to the power of negative something to show it more clear and more easy to express it. So this A got a requirement. Like, let's say I can't write 381 times 10 to the power of 4. This is not a scientific notation. It looks really similar to a scientific notation, but it's not. Because there's a requirement for the A value. A needs to be a number in between 1 and 10. Okay, in between 1 and 10. It can be 3.84 times 10 to the power of 7. But it can't be 384 times 10 to the power of 5. So, and if it's a negative number, then the negative number needs to be in between negative 10 to negative 1. Okay, so same, like the absolute value, like the actual size needs to be in between 1 and 10. You can't have a negative 20 times 10 to the power of something. So that's the scientific notation. So let's have a look how we can express this following into a scientific notation. Well, that's a minus sign. So we just can't, like my decimal is actually at the back, okay, after the last digit. So I will just think about moving forward. This is a larger number, so that will be something times 10 to the power of something. So let's see how many places my decimal needs to move. Okay, 1 place, let's get rid of 1 0. 2, 3, 4, 5, but it's not good yet because it's a 25. I need a 2.5. Okay, I need to keep moving for 1. 6, you need to move it for 6 times. So therefore, that's a 2.5 times 10 to the power of 6. So where your decimal needs to move to, that will be after your first non-zero digit. After the first non-zero digit. Yeah. Oh, sorry. Yes, there's the negative sign in front. Yeah, just put the negative sign. First non-zero digit. Okay, the decimal needs to be after the first non-zero digit. So if you look at the second one, okay, my decimal needs to go from here to here. You go to the left for one time. So that's 3.85 times 10 to the power of 1. And then you also have a 10 to the power of 5 after that. So therefore, that gives you 3.85 times 10 to the power of 6. Okay, times 10 to the power of 6. Okay, for the next one, well, let's have a look at this one. Like, I'll skip that. That's an easy one. Let's have a look at this one. This is a negative 0.0023. Okay, my decimal needs to be here. Okay, after the first non-zero digit. So after 2, needs to go there. So how many times I need to put that? So 1 time, 2 time, and 3 time. I need to move it for 3 times. That's a negative 2.3 times 10 to the power of negative 3. And then times 10 to the power of 2. I have the 10 to the power of 2 after that. So that gives you negative 2.3 times 10 to the power of negative 1. This is the scientific notation. Well, it's not really meaningful if we write things in this way because there's only 1 0, like 0.23. It's still quite easy, but like this question asks us to do it in a scientific notation. That's how we should do it. So when the number is small, then the power will be negative. When it's a really large number, then the power will be positive. You just see whether it's greater than 1 or less than 1. When you have the same base, you add the power. Have the same base, you add the power.
Wait, but why is it negative 3 as the power? Shouldn't it be?
You move it 3. No, it's a small number. It's a number less than, if it's 10 to the power of 3, which means 2.3, you need to move 3 more decimal, like become 2000 something. So that's not right. So you move it to the right, you need to balance it back. So that's why, like you change a number small to a large number, then you need to balance it back. So you need to times 10 to the power of negative.
It has negative 2.3.
Yeah. So it needs to go back. Okay, so I don't think you have problem with expanding those numbers. If you have, like, for example, the first one, you have 10 to the power of 5. So you need to move your decimal 5 times to the right. Okay, 5 times to the right. So 1, 2. And then, okay, you move 2 times, become 9, 3, 4. And then you have 3 more times. You just need to add 0 there. Okay, 0, 0, 0. So when it's negative, then we need to move to the front by 5 times. Okay, it needs to move to the front by 5 times. So that's the number, is here. When you move it first time, it's here, second, third, fourth, fifth. Okay, so you add 5 zeros into the front. So if the decimal is already after the first non-zero number, then all the negative power, you just see what's the negative power, you just add how many zeros into the front.
Wait, could you see the next one?
That one?
Yes.
So you have a negative 2. Shh. You have a negative 2. You need to move to the left by 2 more times. So you add 2 more 0. So you just add 2 more 0. So 1, 2, 3, 4. You need to have 6 zeros. 2, 4, 6. And then that will be the answer. Okay. Just if it's already to the left hand side of the first non-zero letter, you just keep adding zeros into the front when you deal with the negative. Okay, now we start to talk about significant figures. Okay, there are 3, well, actually there should be 4 types of 0. So let's talk about the first 3. So the 0 in the front, the 0 in the middle, and the 0 at the back. Okay, the 0 in the front will not count it as the significant figure. But if the 0 is in the middle, we count it as the significant figure. If the 0 is at the back, for example, 4.20, we say there are 3 significant figures here. So we count it in significant figure. But the basic rule here is we start to count from the first non-zero number. So, well, 0.004010. Well, I start to count from the first non-zero number, which is here. Okay, so 1, 2, 3, 4. There are 4 significant figures. So the front 0, we don't count it. The middle one, yes, we did. And the back one, yes, we did. So that's how we count significant figures. And then the last exception will be integer. It's 3800. Well, if using the rule we have from above, like we start to count from the first non-zero letter, then there will be 4 significant numbers, right? But this one is not true. If it's an integer, there's only 2 significant figures here. We don't count the trailing 0. Like, if it's an integer, we don't count it. Okay, if it's a 0 in the integer, if it's an integer number, you need to start to worry, like, do I have 0 at the back? If we do have the 0, we don't count it. This rule is actually different from what we learned before. Like when I study, like this is not true. This still have 4 significant figures, like when I learned it. But like I think they change it now. Like they don't count this as a 0. Okay, they don't count this 0 as a significant figures anymore. So if it's an integer, you have integer, like it's called a trailing 0. I don't know why it's not counting, but like they make the rule says like integer, the 0 at the back, we don't count it anymore. So, but if I change this question here, 3800.0, then there are 5 significant figures here because it's not integer anymore. Okay, it's not integer anymore. If it's not integer, I can count all the numbers after the first non-zero thing. So I can. This is not an integer, so no exceptional. Start from 3. 1, 2, 3, 4, 5. But this is an integer. We need to think, oh, okay, the zeros at the back of the integer, we don't count it. Okay, the 0 at the back of the integer, we don't count it. But if you have 3080, there are 3 significant figures. We'll count the 3, we count the 0, we count the 8, but we don't count the last 0 here. Okay, there are 3 significant figures. This is just some complex rule. It's hard to explain, but there's basically follow 2 rules. First, if it's not integer, we start to count from the first non-zero decimals. Second, if it is an integer, we don't count the last the 0 in the end. We don't count the 0 in the end. So that's 2 basic rules we use here. Okay, and when number expressed in the scientific notation, 10 to the power of 0 is not counted as significant figures. What we have for A, that's the significant figures. For example, 3.820 times 10 to the power of 5. Okay, so there are 4 significant figures. There are 4 significant figures. So we don't count the 10 to the power of 5, but we only count 3.820. There are 4 significant figures there. Okay. Just quickly tell me how many significant figures are there in the first one? 5, yeah. Second one? 2. Next one? Yeah, 4. 3. 3. 4, 3, number 5. Integers. Okay, it's integer. The last 0 we don't count it. So it's 1, 2, 3, 4, 5, 1 count as significant figures. Okay, number 6. 4. Okay, good. All right. Battery. Okay, next one. Can you tell me how many significant figures are there for the first one? 5. Okay. How many significant figures are there for the second one? 2. Okay. How many for the third one? And last one? Yep. That's a 2. Okay, so now we want to write this number using scientific notation and then only use 3 significant figures. So let's write this into the scientific notation first. Okay, the first one have 1, I need to move 1, 2, 3. So 1.9482 times 10 to the power of negative 3. Okay, that's the scientific notation. After the scientific notation, well, this is an equal. But after that, I only want 3 significant figure. I only want 3 significant figure. I will start from 1.95 times 10 to the power of negative 3. I need to run up a little bit. So I want to only leave 3 significant figures. So I will make it into a 1.95. That will give me 3 significant figures. Okay, next one is an interesting one. If I want to write this into the scientific notation, what I can have? 2.1 times 10 to the power 4, okay? 2.1 times 10 to the power 4. But how many significant figures are there? How many I need? What I need to do? Add a 0 at the back. So 2.10 times 10 to the power 4. On purpose, okay? I need to add a 0. Even though the size won't change, like the size of number won't change, but like I want 3 significant figures. Yes? 4. You add a 0 is the same as you don't have a 0 here. You're not adding, like, enlarge the number. You just keep it as the same. Okay, so you can try the other two by yourself. And the next question is a calculator question. You put that into the calculator, see the number, and then put into scientific. Next one is not hard as well. You can try the rest by yourself for significant figure. Significant figure and scientific notation, they're not hard topic. So you just need to know the rule, and then everything's fine. I'll give you this lesson as like catch up on your homework. So I will check your homework up to H next Monday. Okay, up to H next Monday. You don't need to complete those page before. Okay, you don't need, as I talked about last lesson, you don't need to complete that.